Let's to today's daily challenge question. I only have about 13 minutes left to finish this question. So how to do this question? What is the question? Let's see. Minimum time to complete trips. So we'll be given an array time where time I denotes the time taken by ith bus to complete one trip. Okay. So it means that first bus will complete 1 second to complete one trip, and second bus complete uh, takes 2 seconds, and uh, third bus needs 3 seconds to complete one trip. Okay, each bus can make rock trips successively. It means that one the next trip can start immediately after the completing the current trip. Okay, yeah, got it. So trip of one bus do not influence the trip of another bus, and I mean, so this means that the bus does not need to wait for some seconds to start another trip. It can just after completing one trip, it can immediately start another trip. And we'll also be given an integer total trips, which denotes the number of trips all buses should make in total. Okay, so all buses should make 5 trips in total, and we need to return the minimum time required for all buses to complete at least total trips. Okay, got it. It means, so first bus should also take 5 trips, second bus. So we have bus A, B, C, right? So first bus, second bus, and third bus. So all these buses should make 5 trips. Okay, let's see how much time it takes to make 5 trips. So let's, I'm also writing timeline. 0 second, 1 2 3 4 5 6 7 8. So this is a timeline, suppose. So at 0 second, none of the buses would make trip. At 1 second, so this would complete one trip, right? And this would not complete any trip. And in 2 seconds, uh this would complete, in 2 seconds, this would complete 2 trips. This would complete one trip, and this would not complete any trip. And in 3 seconds, third seconds, this would complete 3 trips. This would complete, um I mean, still in second trip, this would still, the total number of trips taken by the bus is still 3, right? 2 plus 1 3. But in third second, in this would have completed 3 trips. This would have completed still one, and this would have completed one trip. So the total is will be 3 4 5. So it means for all the buses to complete uh, 5 trips at least, um, this would be, this would take at least minimum of, when minimum of 3 seconds, right? Okay, so how to do this question? Let's look at another example as well. So if time is equal to 2, then for total number of trips 1, it would take 2 seconds, right? Yeah, because there is only one bus, and the constraint is the time dot length. Time starts from 1 to 10 to the power 5, and time I total trips. So it means that time dot length, it means that there will at least be one bus, and and the time taken to complete a trip by bus will not be negative or zero. It will take at least 1 seconds. Okay, so I think that how we should approach this question, when I was finding the answer, whenever I was describing this, a solution came to my mind. Like, we could just do a quick, like, um it means that the sum of all the trips would be equal to 5, right? At least 5. So what we can do, I've only 13 minutes left, so better hurry up. 1 to 3, 3 1 1. Approach would be, 3 1 1. approach would be like, for every second I think I should maybe I don't know. One, I mean, I will start from the brute force solution. So the brute force solution would be at every second I would do that, right? At first second, like I did here, at first second it would be first pulse divide by 1. So to find this value, it would be like time I divide by, so it would be method floor, I mean base of time I divide by ith, sorry, time I divide by this timeline. Suppose if I say timeline, then time I divide by timeline, right? Ith second, or you can say if this is j, then this would be, if this is I, then it would be jth second, right? So jth second or jth time. So at jth second, the value would be 1 divided by j plus 2 divided by j, 2 divided by j plus 3 divided by j, right? So I would start from j is equal to 1 to until you know, I would start from j is equal to 1, and when this sum is equal to each greater than or equal to total trips, then return j, then that would be the answer, right? So in this case, when j is equal to 3, then the sum is equal to, sorry, it would be j divided by 1, j divided by 2, and j divided by 3, j second divided by time. So it would 3 divided by 1 is equal to 3 plus 3 divided by 2 each 1. I would only take the base value, and 3 divided by 3 is equal to 1, so 5 would be the answer. But I mean, if this is the solution, then I would have to go, you know, I would have to do this for so many values, right? I mean, I would have to do this iteratively, so it would take O of n for one, for j is equal to 1, it would take O of n time. For j is equal to 2, it would have taken O of n times. So it will take, I mean, O of n times k, where k is equal to, where k is the answer, where k is the minimum time required, right? So I think that we can do this in just O of n time. So how can we do that? Okay. So how to do this? Here we can see that from j is equal to 1 to certain number, right? We are doing it from j is equal to 1 to certain number. So what is a certain number? How far can it go from j is equal to 1 to certain number? Because it will always be from j is equal to 1. So certain number, it can go up to, I think, so if total trips is equal to 5, then it should be, it can go until 5 into 3, right? 5 3 is 15, because if this is equal to 15, then I mean 15 divided by 3 is it would be equal to 5. So at least, yeah, so it means that it can go up to so j is equal to x, where x should be equal to, I mean, x would be equal to maximum time multiplied by 3 multiplied by total trips. So this is our best I mean this is how far it can go, right? Because if this is the value, then we can just where if jth second, right? So if it is equal to x divided by this last value 3, this would be equal to the total number of trips, right? So this alone would give us the answer. So it cannot exceed this value, x value. So okay, what I mean is you can go up to 1 to x. So we know that it will go from 1 to x. It means that instead of linearly going from 1 then increasing to 2 3 4 5 to x, what we can do is we can do a binary search, right? So from 1 to x we can just do, okay, we can go till the middle. So from we can just start from x plus 1 divided by 2, and uh, and that would yeah. So if the mid is less than the value, if this value gives the sum, if the sum is greater, then we look to the left. If it is less, then we look to the right. Okay, this is it. And the time complexity would decrease from O of n to O of n into where k is the minimum time required. So it would in the previous solution it was from g is equal to 1 to x, because we went from 1 to x, but now it would be of n times uh, of n times the log of x, and this would be, in the worst case scenario, this would be less than this value, k value, I think. Okay, so let's do it. I had 2 minutes late. Oh my god, seriously. G is equal to 1. Oh damn, yeah. L is equal to, and R is equal to x each. X would be equal to 2 minutes late. R is equal to total trips multiplied by method maximum of time, and while L is less than R, because we are doing binary search, constant mid is equal to method floor L plus R divided by, guys, I'm racing against the time, L plus R divided by 2. And if I should do this as well. So for const t of time, I'm doing let sum is equal to 0. So sum plus is equal to j divided by 1, right? So it would be j divided by 1, it would be mid divided by t. This is also math.flow. So we are doing sum here, and if sum is greater than the time that we are given here, then I mean if sum is greater than total trips, then it would be, if sum is equal, if sum is equal or greater, if sum is greater than or equal, then we would go left, because we might find smaller as well. So the result is equal to, in the beginning the result would be because even if it is equal to total trips, then we would still go to the left. Or what should we do? If it is equal, then should we yeah, if it is, even if it is equal, then we might find a time that is less, right? So we should still go, the would be result would be equal to mid, and we would still go left. We would still go left, so right would be equal to mid minus 1. And okay, 7 p.m. is crossed. There's a new lead code question now. New daily lead code challenge. Okay, if sum is greater than total trips, then this would happen. Otherwise, if it is less than total trips, then we would go right. So left would be equal to mid plus 1. Okay, so for in the beginning, suppose if it is 1, I mean if time I, okay, and at last return result minimum time. So first of all, L is equal to 1 and R is this, that is the maximum, and we are going until L is less than or equal to R, because we are doing binary search here, and mid sum is equal to 0, and we are calculating the sum required for this time. This is the candidate time, possible time. So this is the possible time, right? Method L plus R divided by 2, and this is the mid time, and we are all doing possible time divided by T method floor sum. And if sum is greater than total trips, then even if it is equal, then we should go left to see if we can find, you know, even less possible time possible. So mean time is equal to possible time, and we are going left, otherwise we are going right. And at last we are returning minimum time. Oh my god. My output is 1 and expected is 3, or 1 to 3 as well. So it means, first of all, let's see, 1 is 1 and the maximum type would be here 3, 5, 3, 15, right? Console that log r method max time. Okay, what should I do? I should do something like this. Okay, so that was a programming mistake. Okay, it worked, but it did not, I did not complete this in time.